Hello everyone. In this video, I just wanted to do a little discussion on variations from our normal distribution that we call skew and kurtosis. So up here in the top left, we have our normal distribution that's following a nice bell curve. Now, the data that is in here is I randomly generated it in some statistical software, and it's not perfectly normal. No data actually is. But let's take a look at this data. So we have a skewness that's very small. So it says negative 0.09. So technically there's a little bit of a left skew. But as long as the skewness is like relatively small, like practically we could say that it is fairly symmetrical, but with a very slight left skewness. And then we have a kurtosis here of 2.75. And when you have basically like no major deviations from normality, your kurtosis is going to be a value of 3. So here I'll just put for mesokurtic, we'll say that that is equal to like a value of 3. Equals 3. And let's go over and look at our skew. So if there is no skew, the skew is going to have a 0 value. And if it's going to be a left skew, like if we look up here where we have some outliers that are being strung out towards the left, and the bulk of our data kind of over to the right, this is our left skew. We have a skewness here of negative 1.3. And this negative skew, like any skew to the left is going to be negative. So we'll just say like negative. And like when we have serious, like the data is actually skewed, like it has a strong amount of skew, it's probably going to be -1 or like more negative. A right skew, on the other hand, if we look at our next plot, this is a right skew. We have a right skew of 1.36. So a right skew is going to be positive, no matter how small it is. As long as it's a positive skewness, then we have a little bit of a right skew. And here we have issues when we start hitting values around 1. But practically for this class, I'm just going to be saying, like, do we have any skewness? Is it positive? Is it negative? Leptokurtic and platykurtic are slightly different variations from our like mesokurtic normal distribution. Leptokurtic has these peaks, like it's a little bit more peaked, and it has a little bit heavier tails down here as well. That's what our distortion is on our leptokurtic. And there are some other options too, or like breakpoints where we talk about when we have problems with things being like a leptokurtic, and it's going to be greater than 3 when we have issues with things being leptokurtic. Platykurtic, on the other hand, notice how it's like we have like very little in the tails, and we kind of flatten out in here. It kind of looks like, I don't know, like a brick. This is something that's going to have or demonstrate some platykurtic traits. And when we have platykurtic, we are going to be less than 3. Oops, sorry. Platykurtic is going to be greater than, or leptokurtic is going to be greater than 3. Platykurtic is less than 3. And typically when we start running into issues here, the issue point is kind of like a +5. And over here we get issues when we start getting around 1. So those are just kind of your technical breakdowns. But these are if we have negative skew, it's left skew. If the skew comes out as 0, it's no skew. Right skew is positive. Leptokurtic, when we use our equation, and in order to calculate skewness and kurtosis, let me give you those equations real quick. So skewness is going to be equals skew, and then you highlight in your data, and kurtosis is going to be equals kurt. That's how you get skewness and kurtosis. And then also just remember that when we have skewed data, if we have skewed data to the left, the mean is going to get pulled to the left. So the mean is going to be less than the median. If we have a stronger positive skew, if we have a skew to the right, that's going to be a positive skew, and it's going to pull our mean higher than our median. Okay, that's all that I have in order to do this little additional video. Good luck.